Hello guys, this is Syed Mohammad Waqas. The topic which I am going to discuss today is related to the drainage pipe sizing. So there I have prepared an Excel sheet. As you can see over here, there's a lot of tables which I am going to use to calculate the drainage pipe size. And this is the drawing for the 9-story building. As you can see over here, it's given here, and we are going to calculate the pipe size for each branch. As you can see, the sections are given as A, B, C, D, E, F, G, H, I, and then stack J, and then run out K, and then we have run out again M. So this is the drawing which we are going to use and to calculate the drainage pipe size. Before starting calculation, I want to give one small message to you guys. If any one of you interested in PhD from Canada, then you guys should visit this channel, Vagabond TV. This channel is related to the PhD in Canada. There you find a lot of videos related to PhD in Canada. So this is really helpful for you guys if you are interested in PhD from Canada. So please subscribe this channel. So let's move back to our topic. So as you can see that there I have a drawing for 9-story buildings, and we have divided each branch. We have given the name of each branch as section A, B, C, D, E, F, G, H, and I. And this vertical stack is represented by J, this runout is represented by K, or offset is represented by K, and then again this vertical stack is represented by L, and this runout is represented by M. So as you can see that I have prepared this table. In branch A, how many fixture unit we have? As you can see over here, we have 70 fixture units. So you have to understand first what is the fixture unit. Fixture unit, if you remember that we have used the fixture unit in water supply pipe sizing. That time it was called water supply fixture unit, and here we are going to do for drainage system. That's why it's called drainage fixture units. So fixture unit basically depends on 3 factors, that is rate of discharge, time of operation, and frequency of use of fixture. So based on these factors, these tables prepared by ASPE, that is American Society of Plumbing Engineers, IPC International Plumbing Code, and UPC Uniform Plumbing Codes. So based on these factors, these tables developed by these IPC, UPC, and ASPE. So I took this table from ASPE, that is American Society of Plumbing Engineers. So based on this table, I'm gonna do the sizing of drainage piping. And as you can see that we have horizontal branch sections given as A, B, C, D is mentioned here in the Excel sheet, and we are going to calculate the pipe diameter. And then we have a vertical stack, that is J, and this vertical stack is represented by L, vertical stack J and L. And then we have offset or runout, that is represented by K and represented by M, K and M. And the list of the fixtures in each branch section is given over here. So for example, branch A, we have water closet, urinal, lavatory, kitchen sink, shower, domestic, bathtub, laundry, floor drain, and bidet. So according to that, we have write the fixture unit value from the table 6.2. So this is the table fixture unit per fixture or the group. So from this fixture we have taken value and we have given it over here. So for example, water closet, you can see the drainage fixture unit value is how much. You can see the water closet over here. So since we are using the valve operated water closet here, so we are going to use this value 6. So water closet drainage fixture unit value is 6. So you can write 6 here. So in the same way, you have to write the drainage fixture unit value for each and every fixture. And then number of fixtures given in branch A for water closet is 5. Urinal we have 2, and lavatory we have 2. So you need to multiply number of fixture with the individual fixture unit drainage fixture unit value, and you will get the total drainage fixture unit value for the water closet in the branch A. So total drainage fixture unit value given for branch A, it will be the sum of all these fixtures. It will be the sum of all these fixtures. So 30 for the water closet, 8 for the urinals. You need to sum up all of these drainage fixture unit value to get the total drainage fixture unit value in the branch A. So total drainage fixture unit value is the sum of all these, that is 70. Same way you have to write the drainage fixture unit values over here in this column for the branch B by seeing the which fixture unit is connected to the branch B. So you have to write the fixture unit values in here and then multiply with the number of fixture unit to get the total drainage fixture unit value. So this is how you have to do for all branches, that is A, B, C, D, E, F, G, H and I up till here. So first we are going to calculate the branch pipe size for branch A, B, C, D, E, F, G, H and I. And second we are going to calculate this stack pipe size represented by J, and then we calculate the pipe size for this offset runout K, and then again vertical stack pipe L, and then again this offset or runout M. So first we are going to calculate the pipe size for this branch A. Since we have 70 fixture unit connected to this branch A by using, and this table 6.4 we are going 6-4 is going to be used for fixture unit loads for sanitary branches. So we are going to use this table 6-4 to calculate this branch pipe size A for all of these branches. So we have 70 fixture unit over here. So as you can see, the total fixture unit we have 70 is in between 20 and 160 and in between 3 and 4 inches. So we will go for 160 on the higher side. So 160 on the higher side, so we'll get the pipe size is 4 inches. So we'll write 4-inch pipe size. And again branch B, that is 90 fixture units. 90 fixture units again come between same table 6-4 we'll use. It's in between 20 and 160, that is we'll go for the higher value, that is 4 inches. So in the same way you have to calculate for this 120 fixture unit branch C. 120 fixture unit is also between 20 and 160, so we'll go for the higher side, again 4 inches. So D has 90 fixture unit, we already calculated. For B it will be same as D, that is 4 inches. Now we'll calculate for the branch E, as 150 fixture unit load value. It's again less than 160, so we'll go for 160. It is in between 20 and we'll not go for 20, we'll go for 60. 160 and pipe size is 4 inches. And then you can see the branch F has 180 fixture units. So 180 fixture unit, it is in between 160 and 360. So we'll go for the higher value 360. 360 we have 5-inch pipe diameter, so we're going to use 5-inch for section F. And then we have section branch G with 190 fixture unit. So in the same way you have to write for G, H and I. G is 190. 190 is also less than 360. We'll go for the higher value, that is 360 is 5 inches. And H is also 160. 160 is in bit 160 is here 4 inches. And then I, you can see, is 200 fixture units. 200 fixture unit is in between 160 and 360. So 360, that is 5 inches. Now we have to calculate the vertical stack pipe. As you can see over here, this is represented by J. So when you are calculating the vertical stack pipe size, you need to sum up all these branches fixture unit load, that is 70, 90, 120 and 90. That is equal to 370 fixture units. So 370 fixture units load will be on this vertical stack represented by J. Now to calculate the vertical stack pipe size, you need to use this table 6-3, that is maximum permissible fixture unit load for sanitary stacks. So this first column is for the, if we have a 3-story building or less than 3-story building, then we have to use this column. If you have more than 3-story building, then you have to use this third column. Since we have a 9-story building, so we are going to use this third column. So since we have 370 fixture units connected to this vertical stack J, so 370, these are the fixture unit values. 370 fixture unit, that means it is between 60 and 500. So obviously we'll go for the higher value, 500. So if you move to the left side, you will find the stack diameter is 4 inches to the 500 fixture unit value. But you need to check one more thing in the last column, that is total discharge in each branch interval fixture unit is 90. This condition should be satisfied, that total discharge in one branch interval should not exceed 90 fixture unit value. But if you go there, you find that this 70 is okay, 90 is okay, 90 is okay, but here we have 120 fixture unit value. So these branches connected to the stack J is not satisfying the condition of 90 fixture unit value. So this is exceeding with one branch interval. This branch has more than 90 fixture unit value, so we cannot take this value for 4-inch pipe size. So we need to increase the pipe size from 4 to 5 inches. So if you select this 5-inch pipe size, you can see in the last column we have total discharge in one branch interval is 200 fixture units. Since 200 fixture unit is the maximum in each branch interval, if you see over here, we have all branch interval less than 200, that is 70, 90, 120 and 90. So our condition is satisfied, so we can select this 5-inch pipe size for this vertical stack J. So this is 5 inches. And then we have to calculate this offset runout pipe size, and the slope which we used in our project is 1/8 inches per feet. So this K section or runout or offset is going to be sized based on the table 6-5, maximum permissible fixture unit load for sanitary building drains and runout from the stack. So this is a runout from the stack pipe, or it is also called offset. So how many fixture unit we have here? Same A, B, C, D, you need to sum up all these branches, that is 370 fixture unit over here. So 370 fixture unit with 1/8 inch slope, so 370 fixture units, it is in between 180 and 390. You will go for the higher value, 390. So for 390 with 1/8 inch slope, you will find 5-inch pipe diameter. Even if you are using 1/4 inch slope, it will also be 370 will also be in between 216 and 480. Obviously we'll go for the higher value, 480. So same 5-inch pipe size. So since we have 1/8, so 5-inch pipe size we are going to use in here for this offset K. And then we have this vertical stack again representing by L. So here if you are calculating the pipe size for this vertical stack L, it will be the sum of all the fixture unit above offset and all the fixture unit below offset. This is the offset, sum of branches above offset, sum of branches below offset, to get the size of this stack L. So we know that 370 here, and how much is here you can calculate, that is 370 plus branch E is 150, F is 180, and G is 190, H is 160, and I is 200. So total fixture unit value to calculate the size of this stack L is 1250 fixture unit. So as I told you, to calculate the stack pipe size, we have to use this 6-3 table. Total fixture unit value for more than 3-story stack, more than 3 stories, we have to use this column because we have a 9-story building. So we have total fixture unit value is 1250. 1250 is in between 1100 and 1900. So obviously we'll go for the higher value, so we'll go for 1900. So for 1900 you can see that 6-inch pipe size. Same time we have to check the total discharge in one branch interval is 300 fixture unit. So each branch interval should not exceed 300 fixture unit value. So let's check and verify the condition. So maximum fixture unit in each branch interval is 200. So it is satisfied, this condition is satisfied that our each branch interval, that is total discharge in our each branch interval, is less than 350 fixture unit. We have a maximum of 200 fixture unit. So this condition is satisfied, so we can use easily this 6-inch pipe size for vertical stack L. And in the end we have to calculate this pipe size for this offset or runout represented by M. So total fixture unit value, it will be the sum of all branches from top to the bottom. We already know that is 1250 fixture unit. So this is runout or offset. As I told you that we have to use table 6-5 to calculate this offset pipe size that is going directly to the manhole, and total fixture unit value is 1250 and slope which we used is 1/8 inches. So 1250 is in between 700 and 1600. So obviously we go for the higher value 1600. So 1600 you can find the pipe diameter, that is 8 inches. So we can use 8-inch pipe size. Again, if you note over here that 1250 is coming in between them, so we'll go for 1920. If you have a slope of 1/4 inches, still pipe size will be 8 inches. So since in our project we use 1/8 inches, so it's the same, that is 8-inch pipe diameter. That value is coming between 700 and 1600, and our fixture unit value is 1250. So we are going to use 1600 and pipe diameter is 8 inches. So M is 8 inches. So this is how you can calculate your drainage pipe size by using the tables from ASPE, American Society of Plumbing Engineers, IPC and UPC, that is Uniform Plumbing Code. But again, I have to tell you one thing, that you have to follow the local codes of your area. For example, if you are working in India, you have to get the values from the local authorities. These tables you have to get from the local authorities, because every region has its own codes and standards developed by them. For example, if you're working in the Gulf region like UAE and Saudi Arabia, Bahrain, Qatar, you have to follow their standards. This is an international standard which I have discussed in here. So I hope you guys learned something from this video. For more videos, keep watching my channel and don't forget to subscribe and don't forget to press the bell icon. Thank you.